Hello everyone. Good morning and good afternoon. Welcome. It's a pleasure to host you on the next webinar from our technical series. My name is Tomasz Jędroszka and I'm heading the data engineering business unit here in Codilime. Today with my great colleagues Kasia Hewelt, the data scientist focused on NLP and LLMs, and Łukasz Rogalski, data engineering technical leader. We'll shed a bit more light on the data engineering area. So how do you think about it in Codilime and how we interact and recommend solutions to our business partners? Before we start, for those of you who haven't seen or haven't had the chance to actually browse through our YouTube channel, I highly recommend to check other webinars there, maybe with an emphasis on the AI ML video. The material presented there goes quite nicely with what we're gonna show today. So getting to the business, now effective data processing techniques, especially in the data heavy environment or big data, if you will. So let me tell you what we've presented for you. And by the way, maybe before we start, in case you have any questions with regards to the material presented, please put them on the chat and then we will have a chance to answer them at during the Q&A slot in the end. All right, so the agenda for today starts with me briefly telling you about Codilime, especially about the way we approach our technical domains, which is most substantial for us, and then how does the data engineering business unit operate in the context of those areas. Straight after that, we're gonna jump to the essence of today's meeting, so actually the common use cases which our team deals with on a daily basis. And here I'm gonna focus on the ways of working and with the data architecture design. Łukasz is gonna dive a bit deeper and iterate through the dilemmas to solve when approaching big data processing, whereas Kasia is gonna wrap up the technical part with a real life example on how to prepare your data before using the ML models in an efficient way. Obviously, afterwards, we're gonna have a short summary of the entire session and then the ability for you to ask questions, yes, during the Q&A. So, a few words about our company. Codilime aims at being a strategic partner, strategic engineering partner, with a focus on supporting technology-driven companies. And our expertise lays with 5 different areas, with 5 main areas, which are networking, equipment, environment, data, and security. What I believe is even more important about Codilime is that we combine the expertise from those areas and provide meaningful and beneficial synergies for yourselves. So good examples of that are synergies between networking, security, enhanced with big data techniques for, let's say, analyzing security breaches in corporate networks. Other good example might be boosting your network performance using programmable equipment, let's say for traffic offloading. But since today's webinar is mostly about data engineering, so let's take a closer look at this particular area. Our expertise here lays in the areas like database tuning, effective data storage, data modeling, visualization, as well as designing efficient data pipelines, especially in the context of big data and data science needs of our customers. So that would be Codilime in a nutshell. Let's move on and present the use cases. First one, to start with, data architecture, design, modeling. So let's take an overview of the factors to be taken into account while sketching your database solutions. So, why is this even an issue? The most important question here to be asked is which database or database solution to choose nowadays. And that became an issue especially after 2006 when the so-called NoSQL revolution started and the number of different database solutions has grown really rapidly. So nowadays, according to Stack Overflow, we have roughly 350 used solutions, quite significant number. And then apart from that, the traditional almighty all-purpose relational database management systems at that time around 2006 started losing their market share in favor of more specialized solutions, and which were often open source. Simultaneously, what it turned out is that the old players were actually raising the bar in the area of single database instance performance, whereas then in the cloud environment it occurred that the true volume has been achieved by horizontal partitioning of many average performance instances. So that's simply because of the fact that it's far better from economical perspective. And then taking this into account, while picking the right database engine for yourselves, it's worth not to follow your biases or past experiences, but actually to do a thorough analysis of the business case at hand, which you have at the moment. And all that means that we, as data engineers, nowadays have huge variety of tools that potentially means that we have far better chance of delivering tailored solution for our business stakeholders. But at the same time, with more options, we have, well, more responsibility, and we need to simply be conscious what we are doing here. All right, and now at Codilime, we deal with customers from many different domains. That means numerous different needs, which afterwards highly impact how we need to approach the data architecture. And then most popular business cases with the emphasis of an area of data engineering would be network / service monitoring, especially in the case when we have real live streamed data. So that good example of that would be, let's say, networking or alerting systems supporting data center operators in their daily routines. Another one, probably also heavy, would be algo trading based on market feed, right? So in those two cases, we would heavily rely on real-time data analysis, where time is a crucial factor. Second most popular, multi-source data ingestion and integration. Here, a bit different approach. So here the focus would lay on proper, flexible data modeling, normalization, where afterwards we can have all those streams integrated and presented, and then the user can browse through an entire data set. So connected with the earlier ones, the data cleaning and wrangling, for example, for the purpose of AI modeling, here the challenges and techniques will be soon described more thoroughly by Kasia, so I will not steal her punchline, but you will hear about it soon. So further case, still very valid, which is data warehousing and BI. Classical solutions still used, greatly support retail business. So that's mainly for the purpose of generating reports and forecasting the demand for those retail businesses. Another one, graph solutions. In Codilime, well, there are different areas, but in Codilime we mostly took benefit from it for the purpose of fraud detection or, let's say, recommendation engines. And then last section containing of two items would be the newer use cases, newer to us, newer to the market. Blockchain, which is an emerging area, well, still emerging area for the data engineering. Here, concepts like smart contracts, consensus algorithms, decentralized storage or processing, and NFTs. Crucial part here is that your algorithms and data structures are very precise and concise, right? So you can take most benefit of those techniques. Lastly, LLMs and GPT, extremely popular topic nowadays. So as an industry, I believe we're still learning how to approach it efficiently, but simultaneously at Codilime already delivered a few nice projects based on so-called hyperlocal LLMs. So mainly for the sake of customer support divisions, and also for the sake of efficient browsing through robust company resources like Confluence or document stores.
I would like to add something. So hyper-local LLMs are relatively new term. And it is with the revolution of large language models, we have a lot of solutions right now available. And for example, we have a lot of local models available, and they are working very well with special ecosystems where you can train your own custom knowledge base. And this is extremely important to protect your data, because in your company you have very confidential data, and right now you can train it with your custom knowledge base with those local language models.
Yeah, so thanks to that, your proprietary data actually doesn't leak outside of the organization. So that's important, I believe, to mention here. All right, but beyond the business itself, so there are plenty of factors to be considered, technical, non-technical factors. This is a very broad topic for a webinar of 30 minutes, but let me give you some examples that I think are the most important here to mention. So to start with, simple as that, whether your solution will be more focused on reads or writes, right? Simple question, but then this metric, the impact of this metric can go as deep as how your hard drives should be configured and what should be their type, right? So it's important to mention. Afterwards, let's say the distinction between whether your daily routines will be row-based or rather you're focused on more broader business analysis. So especially in the world of big data, what is usually important is the trend. So users pay attention to the general impression, and that's a value in itself. Whereas in the, let's say, in the financial domain, you're obviously interested in getting precision on the level of a single row, and it needs to be super precise and exact. So this would be it. Furthermore, data consistency level, and to make it simple, let me turn this into a question. So I would ask, does every single change in your system requires to be visible by all the users and at the same time? So sometimes the answer is yes, but very often the answer is no, which means you can greatly improve your overall system performance in that scenario. Going forward, the supported data types in your ecosystem, the schema flexibility, or potential need of complex queries generated ad hoc. And these are especially important from the perspective of daily usage and maintenance. And as an example, how you can benefit from a database solution that gives some capabilities natively, let's say simple as JSON querying, right? So in this scenario, your power users, not every single user, but power user can do many of the work ad hoc themselves without support from the development teams, which actually gives you a huge bonus in case of our ROI, return on investment. So that's worth to mention. Next, well, the big one, processing cadence. So that will be later on covered by Łukasz in detail. So I will limit myself to a simple fact and constatation that if your cadence is not that high, and well, there are examples where the cadence is for let's say monthly, it's worth to consider a dedicated on-demand solutions greatly available at the moment that would allow to keep your infra costs at a reasonable level. So important to mention. Lastly, but this bullet point can erase all the ones mentioned beforehand. Time to market. Very, very common case is that the business demands a good enough solution, but here and now, and then obviously you need to deliver. All right, a short summary of this section. As usual, without good analysis, help from your subject matter experts, spending time on architecture sketches, you may easily end up in a costly, inefficient solution, so which would bring more harm than profit. So it's important to take this time. As said before, there are many solutions to pick from, but you need to be aware of pros and cons. You need to pick your crucial priorities and then design your solution to cover the crucial priorities. If something would be aiming at doing everything, probably it won't do it really well. Worth not to forget, systems nowadays barely exist in silos. Integration with other subsystems will happen sooner than later. It's good that the design solution is well documented and straightforward. And in the end, the data layer is important, is significant, because the wrong design of it will impact all your business, most probably will impact all your business operations and the performance of your applications. And even more importantly, if you think about the deeper, due to it is known fact that the data layer outlives very often the software on top of it. So with that thought, I will wrap up this section and pass the mic to Łukasz.
Thank you. Okay, so hello, welcome everyone. Tomasz, thank you for this warm introduction. So during this section, I would like to elaborate about fundamental principles of data processing at scale. Intentionally, I will not dive into specifics of particular technology. In contrary, I would like to focus more on principles and structured approach into big data problems, and just hopefully show you how certain techniques can help you with managing these complexities. And with that in mind, let's go. So batch and streaming. So concept of batch processing and streaming processing arise very quickly in any system and starts at data ingestion stage. In streaming framework, continuous, very often immutable event stream is captured and sent to system online. Typical examples may be customer transactions or telemetry data, but also very often, sometimes due to technical limitations and sometimes due to business-specific reasons, batch processing is used. And in batch approach, larger data sets are ingested into system in bulk. So going back to aforementioned customer transactions example, maybe instead of consuming them online, we load all of the transaction after closing business hours at the end of the day. And all of the transactions are ingested in one go. Of course, this distinction between batch and streaming does not only hold for ingestion stage, and depending on functionality of the system, depending on requirements, downstream processing will also be done either in batch or in streaming fashion. I think it's very important to note that very often we get a combination of both. One very intuitive example would be any machine learning inference system where large corpus of data is used and processed in a batch fashion to train a prediction model. And with growing model sizes, the effective processing over there is extremely critical to get those models quickly and hopefully cheaply. But once the model is trained, it can be used either in another part of the system, which is either uses batch processing as well, but also may be used as real-time to process real-time streaming data. So obviously you have different technologies optimized for batch, different technologies optimized for streaming, and so this technology selection, as Tomasz was mentioning previously, there are a lot of technologies, but technology selection is always done in context of your business and in context of your data, in context of problems you're trying to solve. Following on this idea of batch and streaming, and very closely related to that, we have to mention concepts of latency and throughput. The significant questions the question you have to answer is whether your system is a real-time system and is supposed to answer within certain time limits or not. So some of the use cases mentioned by Tomasz earlier, let's just say BI, for example, are often satisfied by complex queries, but queries which are effectively processed offline and served, and they do not require the real-time feedback to the user. In other use cases, let's just say any anomaly detection, fraud detection, the latency, so the response time is critical to the functionality of the system. So it's extremely important to keep that in mind. So this is a trade-off that you have to do. If you will optimize for response times, you will most likely get lower throughputs. If you will optimize for throughputs, you will get higher latencies. So those trade-offs have to be evaluated accurately. Once again, in context of problem you're trying to solve, in context of your business, and in context of your data. So about partitioning and sharding. So regardless if we talk about data partitioning in OLAP systems or sharding in more classical transactional databases, the fundamental idea behind those is similar. By leveraging the fact that your data is distributed and by leveraging how it's distributed, runtime performance of your system can be vastly improved. Reads on partitioned data can optimize not needed data scans. For some managed solutions, data scans are part of the overall billing. So this means you will not only reduce your runtime, but also your costs, your expenses. And read writes on sharded data will help you achieve more uniform loads across your infrastructure and effectively utilize your resources more effectively.
Yeah, I think this part about cost is also significant nowadays when many organizations actually pay a lot of attention to cost reduction. So
yes.
Good that you mentioned that.
Yes. I would also like to underline the fact so we are seemingly talking about performance improvements, non-functional improvements, but in practical terms, it's not even an optimization. It's often it's a necessity to achieve the behavior of the system, the desired behavior of the system, especially when your data you are handling is growing. So so that's the concept. Of course, the precise strategy, how to partition, how to shard your data, will vary from system to system, will vary from problem to problem. You have to analyze that in context of what problem you are trying to solve.
Hashtag it depends.
Yes, as usual in engineering. Parallelism. So another critical concept of any big data system. With sheer amounts of data that you're wrangling, that you're processing, you most often cannot achieve reasonable processing times on a single machine. So effectively what you're trying to do is you try to process them by dividing your jobs into smaller tasks and processing them in parallel across multiple machines. Of course, the idea is simple. In practice, it's not so easy. It's not as easy as it sounds. If your queries will require some form of synchronization between each other, between each of the tasks, the overall query performance will slow down due to the synchronization bottlenecks. This impact will be more and more severe with your data sets growing. So we have to be mindful of risks like that. Analyzing query plans and execution plans is a great way to consistently identifying those problems and eliminating those. So in terms of parallel processing, parallelizable queries are very valuable if we're talking about batch processing in cloud. Very often cloud vendors allows you to rent cheaper compute instances. at discount, but they do not guarantee. But effectively, cloud vendor is allowed to evict you from this instance if any other customer needs that. But those instances, those cheaper instances, combined with resilient frameworks, which are able to handle errors and resubmit failed tasks, can allow you to get the processing you need at discount in cloud, which is, of course, important in terms of managing your cloud costs. Pre-aggregates. Pre-aggregates are fairly intuitive. So if you recall my previous slide, with partitioning, I was mentioning that one of the goals was to eliminate unneeded data scans. So you have the same goal with pre-aggregates. So you hope to run your queries against smaller tables of pre-aggregated, pre-computed data and get the data you need with lower query runtime. So, of course, the idea is simple, but the practical implications are a little bit complex. System if you introduce pre-aggregates, system will become more complex. Those pre-aggregates have to be maintained, have to be refreshed periodically. System inherently becomes approximated in some of its aspects. Of course, if you have quickly changing data, your pre-aggregates will diverge relatively quickly. So you have those risks, and you have to keep those risks in mind. But nevertheless, this is a very powerful technique. Such approach is often needed to achieve acceptable performance, especially if we are talking about real-time systems where response time is actually critical. So summing up, virtually all of the technical decisions that are done in big data space are analyzed in context of your data, in context of your business, in context of problem you're trying to solve. There's plethora of technologies, but there is no one silver bullet. There is no one strategy that will solve all of your problems. At the same time, I would strongly recommend not to reinvent the wheel, at least in the initial phase. Known techniques, known industry-proven techniques, when applied consciously and consistently, can help you solve a lot of your problems effectively and easily. And last but not least, you have to be aware, at least roughly, what happens under the hood. If your system starts to process bigger and bigger data sets, it will have overall impact on the performance. There's no way around that. So you have to evaluate the situation you are in. You have to evaluate it correctly, make an educated decisions, and apply trade-offs in the places where are needed in order to limit this impact. So naive solutions, naive approaches over simplistic approaches are rarely an effective one. So you have to keep that in mind. And this will be all from my side, and I will pass the mic to Kasia. Enjoy.
Thank you. Okay, let's discuss right now the importance of data pre-processing. So as Łukasz has mentioned in the previous slides, data pre-processing at scale is no easy feat, and a couple of factors should be taken into consideration. Regardless of the size of your data, proper pre-processing is critical to ensure accurate and reliable results of your machine learning modeling. That's why in the next slides we'll be discussing the essential steps for preparing the data for machine learning, and we will be discussing the modeling phase, where we will learn how to build, how to train, and how to test our model. Lastly, we will evaluate the performance of our model to ensure that it fits the data. These steps are crucial for any machine learning project. That's why we will discuss each one of them to help you better understand the process. Okay, we'll start with data wrangling, and this is the vital first step after, of course, collecting the data. And it involves cleaning, transforming, and preparing the data for further analysis and machine learning. And this process of data wrangling ensures data accuracy, completeness, and compatibility with machine learning algorithms, leading to better insights and decision-making in the end.
If I may, Kasia, I think this is extremely important to pay attention to this part, because one important thing to understand about ML is the quality of the data you feed it with will impact what you will eventually get out of them. So, well, there is a saying, garbage in, garbage out, right?
Yes, exactly. This is a very popular term in the data world that basically means garbage in. So if we feed our machine learning algorithm with garbage, with not processed data, with noisy data, then we get garbage out. We will not get accurate results. We cannot really take any insights, and we cannot make good decisions for our business. So this is an extremely important term, garbage in, garbage out. And how we can handle that? There are a couple of methods in data wrangling, and one of them is handling null values. Handling null values is essential for avoiding bias or inaccurate results and maintaining model performance, as most machine learning algorithms require complete data, so we cannot put missing values to most of the machine learning algorithms. And the methods include, as you can see on the slide, removing or inputting missing values with reasonable estimates. Another method, another data wrangling process is encoding categorical variables. And this is basically converting text or string values into numerical values. And this is also crucial for data preparation, since machine learning algorithms work with numerical data. And this process reduces dimensionality and enables efficient analysis and modeling. Common techniques include one-hot encoding, label encoding, binary encoding, etc. Okay, and understanding the significance of data wrangling for machine learning, let's look at the handling null values using some visualizations, like in the slides example. You can see enrolled university variable distribution. It comes from a public Kaggle dataset. You can see the full code on our GitHub. The code, there is like data wrangling part also and modeling part, so you can examine, you can check out the code later. It's available. And seeing null values as a minority, we can easily replace them with the most frequent values. And this is a very common approach for categorical data with few missing values. Additionally, this is a categorical variable, so we need to convert it into numerical values. And one-hot encoding is suitable here, creating binary columns for each category, allowing machine learning algorithms to treat categories equally without undue influence. Okay, data preprocessing challenges include, of course, handling null values, encoding categorical features, and some more. Another common challenge is imbalanced target variable distribution in classification problem, which can lead to biased model with poor minority class prediction. As you can see on the slide, we have two classes, 0 and 1, and you can see that 1 is the minority, and the difference is huge. And to address this issue, we have several techniques like oversampling, undersampling, SMOTE, and they are all used to balance the target variable and improve model's performance. Undersampling removes samples from the majority class, and it's suitable for large data sets, while oversampling duplicates existing minority samples and works well for limited minority class data. The choice of technique depends on the problem. Again, hashtag it depends. In the presented slide, in our sample data set from Kaggle, oversampling seems appropriate due to the data set size. In machine learning, we evaluate model performance using a training set and a testing set. The training set is for model training, while the testing set assesses the model by comparing predicted and actual output labels. Common data set splits are 80-20% or 70-30%, and the bigger part goes to training set. What is important, preserving data distribution in both sets prevents bias, ensuring the model fits well to the new data and performs efficiently in the real-world situations. During the machine learning process, we choose a suitable model or combination of models based on the problem type and the data itself. Regression predicts continuous output variables such as price change, while classification predicts categorical outputs. And in our GitHub repository, we tackle a classification problem predicting job change willingness, hence 0 and 1s in the previous slides on the visualization. After selecting and training the model, we validate and adjust it to ensure good performance on the new data using techniques like cross-validation, for example. Finally, we test the model on a new data to confirm real-world effectiveness. And how do we know the model is performing well? As I just said, we evaluate models' performance on a testing set. And the right evaluation metric is critical for measuring effectiveness and guiding good decision-making for your business. In conclusion, data preprocessing is a critical step in machine learning workflow that requires careful consideration and attention to detail. By following best practices for data preprocessing, we can improve the accuracy and reliability of our models. We can also gain good insights into our data and ultimately make more informed decisions which are driving our business. Thank you for your attention, and I hope this presentation has been helpful in your understanding of data preprocessing for machine learning.
Well, I actually think all the use cases were helpful for you guys, especially. So to summarize, well, first things first, I'm glad that, well, you were with us throughout this session. I hope it became clear that the way to achieve your goals in the data engineering area is through a good understanding of your use case at many different levels. So starting from your data architecture design, modeling your data intense processing, and afterwards preparing your data for particular pieces of analysis. So wrapping up, we all are wishing you good luck in your data endeavors. In case you'd like to chat more, feel free to reach us via LinkedIn, via our other social media, or via our data engineering questionnaire. If you decide to fill it in, we will return with some initial analysis, possible recommendations, and then we can see how far we can get from there. The link should appear on the screen. Also, probably it's going to be visible under the video. So yeah, once again, thank you for your attention. And now we will give you the mics or keyboards and wait for your questions. So time for Q&A. Do we have any questions?
I'll check out our meeting chat, and meanwhile, we're waiting for your questions. This is not our last webinar, so make sure if you would like to stay up to date, join our social media or LinkedIn. We are posting all the events there.
Yep, and I can see there is a first question. Well, actually, it has been there for some time. I have a question from John Morgan. What is your opinion about recent open source developments in large language models comparing to OpenAI ChatGPT?
Very good question. Do you want me to take it? Okay, so from what I've seen, looks very promising. First of all, the fact that those are open source developments instead of just proprietary solution like OpenAI seems to be a big benefit. So going back to what we discussed a little bit earlier, the ability for you to self-host it and protect your data seems to be very important. The other very impressive thing is just the accuracy that those open source developments are able to achieve with much smaller model size comparing to ChatGPT. So this means that it can be used it's just a little bit more efficient in terms of time, but also I think it opens the possibility of retraining your model. I mean the retraining model and getting to like put your knowledge, your domain specific knowledge into this model instead of just general language model starts to become more practical, which is also quite interesting avenue.
Let me elaborate a little. So as I already mentioned, OpenAI, ChatGPT are obviously ChatGPT, GPT 3.5, GPT-4, or different models, language models from OpenAI are obviously very powerful and very good tool. However, we are still kind of selling or publishing our data for training purposes, for OpenAI training purposes, and those open source developments in large language models, especially local language models, which we can download on our local machine and train it with our custom knowledge base, gives us a lot of possibilities and a lot of opportunities, because we can, for example, create our chatbots or anything with our custom data. We are not selling our confidential data anywhere else.
And also the set of models is expanding every day as far as
Yeah.
I recall recently.
Yeah, 2023 is not only year of AI, but also large language models and its development.
Yeah. Okay, guys, are we good with the question? Should we proceed?
Sure.
All right, so the next one. Hey guys, great conference. What do you think about DBT and DuckDB? And there is another line. It's been a lot of hype with this stack, even saying that is greater than Spark for processing small, medium data sets. Well, maybe I'll pass eventually the mic to Łukasz, but I would say, well, what do you think? As probably our whole presentation said, actually it depends, because it depends on your use case, how and what particular solution would you like to use for it. But Łukasz, do you want to extend?
We use Spark in production, we use DuckDB in production. Looks promising. What more can I say? It's, as I was saying, the technology choice is highly dependent on what exactly you are trying to solve, what are your functional and non-functional requirements. What can I say? DuckDB looks promising, for sure.
So hopefully that at least in some part answers your question. If you would like to elaborate, again, as it has been said before, reach us via either questionnaire or LinkedIn. All right. Another one, can you talk about the best practices for updating ML models in production? For example, how do we version them and how do we ensure that the accuracy is continuously improving? So you're probably talking a bit about MLOps. Guys?
I think we are still discovering it.
So there's obviously a part of. So there are two parts to the question. First part is how you measure your model, and I think Kasia, you can dive a little bit more into that. And the second part is the ops part. So how you actually deploy. So do you?
Yeah. Sorry, I thought it's about large language models, which we're still testing, but about machine learning models. Of course, like how do we measure the accuracy? We do choose appropriate metrics, and model evaluation is not just done once. Once the model is pushed into the production, you're constantly checking its performance, and if it's fitting well to the new data, the data might change, so it also sometimes needs to be retrained again. So yeah, once pushed to the production, the constant evaluation, the constant maybe retraining as well should take place.
Yeah, and if I may, I think you've hidden actually the one who asked the question, hidden a part of the answer within the question. It's important not to do your experiments on the site, but let's say using Jupyter notebooks, for example, but also to version them to keep particular experiments in some sort of repo, right? So you know that this particular version of the experiment gave that particular metrics or outputs, right? If this is lost, then you're in the woods. You will never know what experiment gave what results.
There are some libraries like which are supporting AutoML, for example, H2O, where you can save your metrics from the previous training. And for example, this H2O package helps you with retraining the model and saves the metrics, so you can compare it and have freshly trained data all the time. Oh, depends how often you would like to train your data.
All right, Łukasz, anything else? Are we good?
I think we are good. If we were talking about ops part, there are obviously things like A/B testing. You can release different models, different customers. There are a variety of techniques that you can use, but ultimately you have to measure. You can't guess. You have to measure, and you have to automate your rollouts to make it reliable. That would be all from my side.
Okay, thanks. I can see there is another question. What is your approach to keeping the cloud computing costs at the reasonable level? Well, I think we a bit covered that during the webinar, but well, let's address it more thoroughly. So, well, first things first, you definitely need to be aware what are the sizes of your virtual machines, of your database solutions. Obviously, cloud providers give you lots of opportunities. One to measure, another one to scale them up, down, and so on and so forth. So that's one thing. So you need to first identify the resources. You need to know what you have, and then evaluate them periodically. Right. So. Another popular technique which we also recommend is setting up some sort of resource monitoring solution, maybe more robust one than the cloud providers give out of the box, to know which exact areas produce the highest cost, and then obviously focus on that according to 80-20 rule, right? So hopefully that answers your question. Great response. Can you also check web page by Neptune? Okay, I believe that's it. We don't see any more questions in the chat. So seems we've covered all the topics. So anything else, guys, we wanted to mention before wrapping up?
I have a small announcement. After this webinar, you'll get a very short survey about your impressions. Me and my team will be very grateful if you leave us some feedback. Thanks again. And thanks to that, we can constantly improve our webinars. Yep. Thank you in advance.
Thank you so much, guys. Thanks for joining again. And then see you on the next webinar from our series. Have a good rest of the day. Bye-bye.
Thanks. Bye.
Thank you.